Cool. Okay.
Thanks.
Hello. So, I like to start these talks just by asking for a brief show of hands. How many of you are using .NET Core in production at the moment? Yeah, you can raise your hand, Gary. Cool. Is there anyone here who's yet to be convinced about .NET Core or thinks it is maybe the wrong move for Microsoft? Cool. I've been giving this talk for about 3 years now. We used to get a few people who started raising their hands going, I don't really think it's the right thing, and that proportion has gradually gone down. As the proportion of people who are actually using it has gone up, so that's interesting. So I first started giving this talk back in, I think it was 2016, and back then the conversation was really more about what is .NET Core and why should I care? And when I started giving it, I used to start off by saying that in about 5 or 10 years' time, it would be a bit like MVC all over again. 5 or 10 years' time, .NET Core, I said, would be the thing that people are writing software in, and the full .NET framework with web forms or WinForms, we'll get onto that later, are going to be the legacy things that you're going to be trying to escape from. 3 years later, just from checking recruiter spam, apologies to any recruiters who are in here tonight, but just from seeing the spam messages coming through going, do you want to be a third-line developer? No, you're right, Tom. More and more of those are starting to mention .NET Core. And I'm sure a lot of those are places that have huge monolithic legacy applications, and we do .NET Core because we've done a few little bits to one side in .NET Core, and Gary can put his hand up here again because Gary works with Cascade and he knows exactly what I'm talking about. But it's gradually becoming more and more mainstream. If you're struggling to persuade your boss why your business should invest in .NET Core, it's a really simple answer. You can put it in commercial terms that your boss is going to understand. And the simple answer is, it is going to get more and more expensive to keep hiring people who want to work on legacy software. And old school .NET is inevitably going to become legacy software, and it's going to cost you more and more to keep that platform going. Whereas you can hire a load of really cheap graduates who will work loads of hours for not a lot of money because it's new technology, and you can exploit the hell out of them, and your boss will love that. So you can invest in .NET Core, speaking as a dev manager. So who am I? I'm Keith. I've been working with the web and ASP and ASP.NET generally since about 2003. Didn't really get into ASP.NET until about 2005 in the .NET 2 era. By about 2007, I really felt that .NET was a bit uncool and was thinking about moving into Ruby on Rails. And then happy days, MVC came along, and I got back into .NET. By about 2014, I was bored again, considering moving to Node, and then happy days, .NET Core started coming out. So .NET's keeping me busy on a regular basis. One point it might get boring enough that I move away. I've been using .NET Core in production since 2016, and I've been playing around with it in one form or other since about 2015. I've been through all of the betas, I think one of the alphas, deployed my first production application on beta 4 back in 2016, which I didn't tell my boss at the time that it was a beta. He had kittens later. But it worked. It was fine. It was fine. So, yeah, I've seen the pain of upgrading each version of .NET. I'm by no means an expert. I currently work as a development manager for Cascade HR. If you happen to use Cascade HR, see me later. I'll see what I can do about your support tickets. I can't do anything about your pay slips, unfortunately. That's locked down. So I'm by no means an expert in everything. I'm not a full-time developer anymore, but I've been through the whole journey of .NET Core. And hopefully I can give you some interesting information about it. So we're going to talk about a few things. First of all, I like to start by talking about the history of .NET Core, because unless you understand why it happened and the problem it was trying to solve, it doesn't make a huge amount of sense as to why it is the way it is, or why Microsoft have broken the things they've broken or moved in the direction they're moving. And also my training academically is as a historian, so I like to start with a history of things. Then we're going to move on to more interesting technical conversations around what it is, how it works, and what the moving parts are. There's some new information around what's coming in .NET Core 3, which changes some of my slides a little bit. It changes the focus as well of how you would look to migrate to .NET Core 3. There are some big changes coming in 3 that are going to possibly present some more obstacles and maybe make it a bit more urgent that you start thinking about migrating. We'll look at some different migration strategies, hopefully give you some tips and ideas on how you could start using it now, even in legacy applications, or at least start getting it ready or getting it into a state where migration becomes a lot easier. Then we're going to have a break. Then we're going to look at a live demo, which means you get to laugh at my terrible code, but it'll show off some of the features of ASPNET Core, and then any questions afterwards. And if anyone's got any burning questions while I'm talking, just shout out. I'll do my best to answer them. So the history of .NET Core. Now, I love .NET Core. It's been the thing that's kept me interested in .NET for the last, 4 years now? But from the outside, you could be forgiven for thinking that history is perhaps a little bit of a car crash. If you've seen the betas and the braking changes and the dead ends and the roads not taken and the reversals and all that stuff, it's all been considerably messier than you might be used to from previous Microsoft releases. Now, previously, with Microsoft, you got a release every 2 years. New version of Visual Studio, new version of .NET, new WinForms, everything comes out new version of Office at the same time, thank you very much. Go and report the bugs and we'll fix them in 2 years' time. .NET Core hasn't been like that. Microsoft have taken a very decisive pivot towards openness, open source, and just open in terms of the sort of arguments that previously would have happened in closed offices or meeting rooms on Microsoft campus between their product managers and their developers, the same sort of arguments we all have day in, day out about should it do this or should it do that, or oh God, those designs don't work, we need to go back and revisit them. You wouldn't have seen anything like that before, and now it's on Twitter, it's on community stand-ups, it's all over the internet, and we see all the gory details. Which means that if you're not really involved in it, it can seem like a bit of a mess. The good news is, a lot of that is now behind us. We're now at .NET Core 2.2. .NET Core 1 was a fair while ago. It's now pretty stable. I say pretty stable. There's still a few things that are catching up, Azure Functions being one key example, as Kev will tell you all about. But we're now at a point where it's stable, it's good, and upgrading from, say, Core 2.1 to 2.2 is pretty straightforward. So if now is the first time you want to dive in, it's a good time to do it. Diving in back in 2015 was interesting. It was more a case of how does this work, can this work, and why doesn't this work, whereas now it's a lot more straightforward. Some people to follow if you're interested in what's going on in the world of .NET. David Fowler is pretty much the architect of what used to be ASP.NET 5, from which .NET Core has all come. The initial alphas were pretty much whatever they could scrape off his machine and chuck into the world. The joke in Microsoft is that .NET Core exists because he got a MacBook and wanted to write code on his Mac. Damien Edwards, who's the product manager, so he owns .NET as a application frameworks as a product, so MVC and things like that, Signal R, are all his. Because .NET Core has been a lot more open, you've now got people like Ben Adams who have come along. They don't work for Microsoft, but because the source code is open, they're coming along and going, ooh, tweak that, I can make it a lot faster. That's also been quite a big cause of the long development journey for .NET Core, because as people like that have come along and gone, you could tweak that, you could tweak that, you could tweak that, it's no longer a closed shop where Microsoft can run along according to a plan. They've got new stuff coming in, and it's caused them to go, ooh, actually, if we did that right, we'll push that release back, we'll do that first. All this stuff sort of now comes into play because it is a more open development environment. And Scott Hunter, who is the director for all of .NET, he came in either 2016 or 2017, I think. Previously, the ASPNET side and the desktop side were different divisions, which is why ASPNET 5 was ASPNET 5 and not .NET 5. When Scott Hunter came in, he decided that was a load of rubbish and unified it all, and it then became .NET Core. And at that point, the whole delivery pipeline just sort of ground to a halt while they went back and hastily had to go back to MS Build and CS Proj and XML project files and ditch a lot of the stuff they were doing for ASP.NET 5. If you want a timeline of that, it starts back in 2014 as Project K, and really back then it's an attempt to be Node, but in .NET, because Node back then is the cool hot thing, and that's Microsoft's attempt to say we can do that too, and they promise it will be in VS 2015. Then by 2015, it's no longer Project K, it's now DNX and DNVM, if anyone remembers those, .NET Executable and .NET Version Manager. All really painful betas start coming out now. You get breaking changes constantly, and it's all a bit of a churn, and there's flame wars on Twitter between different people who want different things out of it. And they promise it will be in 2017. 2016, as I said, Scott Hunter takes charge of it, turns it around and changes the whole roadmap, as people like that tend to do. It now becomes .NET Core, and Roslyn comes out at the same time, which is the brand new C# compiler, which underpins a lot of the .NET Core work. Finally, in 2017, we get 1.0, which, if I'm honest, is really a bit more of a release candidate. But doesn't matter, it's 1.0, therefore we can now officially put it into production, and our CIOs don't have kittens about it. .NET Core comes out pretty soon after, and suddenly a lot of things become easier, and VS 2017 comes out, and it's more or less baked in now. 2018, .NET Core 2.1 comes out, and the .NET Core 3 roadmap is announced. That's actually a mistake. 2.2, I think, came out in 2018. And here we are in 2019, and we're looking forward to .NET Core 3. And that's going to be interesting, because in .NET Core 3, we get WinForms back, which is really interesting. That shows you just how mature, if you want to use that phrase, Core is getting, to the point where the oldest, scrottiest of desktop platforms that Microsoft do, though I quite like WinForms, are going to be supported in a world of .NET Core. So what were the drivers? What I mentioned before that we were going to talk around why .NET Core is a thing, and there's a few reasons, I think, key reasons that got us to where we are. I mentioned earlier that people were getting Macs, and there's been a greater drive for cross-platform development. There's also been a greater drive for things like Azure and AWS. As cloud platforms get more popular and applications have greater needs for scaling, you're no longer looking at one big web server, you're now looking at farms of, at Cascade we've got 12 in ours, other platforms have dozens. Economies of scale matter. It's considerably cheaper to license, or not license Linux, than it is to license Windows. Linux starts to win the cloud server war, or at least there's a push from people who own the budgets to go, wouldn't it be great if we could move over to Linux, save ourselves a huge amount of Windows licenses, at which point we go, well, we're a .NET shop, we can't support Linux, and a lot of .NET developers start getting very nervous. So Microsoft needed an answer. They needed a cross-platform development environment, which they didn't have in .NET. They had a Windows-only platform. They also had in .NET a platform that still had support for ASP. We've still got a classic ASP in our application. You can change the file extension and put an X on the end, and it runs in .NET. You can include classic ASP files in ASPX files, and it will run. There is a huge amount of legacy support in IIS and ASP.NET and .NET as a whole, going all the way back to ASP, back when it was a come on, let's get on to .NET. It's the new thing. ASP's the old thing. That's not very cool anymore. It'll work. It'll be all fine. You can just put an X on the end. It'll all run. All that's still in there. IIS still has to go through all of that. And all that sort of legacy cruft is what really blocked .NET from being the sort of high-performance web framework that Java could be. That's why .NET got a reputation, or partly why .NET got a reputation for being considerably slower. Node, obviously, was big and felt a lot different from Visual Studio. Very command-line driven, text, readable text files, editable text files. Whereas with .NET Classic, you've got a framework that's oriented around paying a few £1,000s for a big IDE that manages these hundreds of lines of XML for you, but you just don't touch them. You just let the IDE do it all. That philosophy is very much going away. And we're going back to CLIs and project files that can be human readable, so we can just edit them, so you don't have to pay for huge IDEs, and you can use Notepad++ or VS Code or Sublime or Atom or whatever to edit these things. The rise of Docker. .NET is very much a big, heavyweight platform that expects to have frameworks installed on machines, that expects to have things installed in the GAC and so on. Docker, you're moving into a world where applications need to be small and lightweight and portable, and you can just fling them onto a box and it will just run out the box with everything it needs on it. Again, with classic .NET, that's difficult to achieve. So there needed to be a bit of a stripped down approach to get into that market. And that also ties in with the DevOps movement. We're no longer in a world, or we shouldn't be in a world, I know a lot of people still are, where you've got a server admin who knows how to configure the magic web server. And he's got a 20-page run book for setting the right settings up on IIS, and he ticks these buttons, and you don't touch the web server because it works. We're now in a world where all of that has to be scriptable and scripted, ideally, which means that configuration needs to be easy. Applications need to be isolated. You need to be able to just chuck these applications onto servers, or server farms, or cloud services, and they just need to run. We've also I've mentioned this before, we've kind of been here before. If anyone remembers this is from back in 2007, 2008, no, 2007. And this was the announcement for MVC when Scott Guthrie first proposed it as a thing. And back then, I distinctly remember an architect I worked with going, "It'll never take off. You might get a few shops who want to do some hardcore web dev, and they might use it, but the bulk of the industry, they'll use WebForms because it's rad, it's rapid application development, it's drag and drop, and they love that." How many people want to work with WebForms? Yeah, it's done exactly what .NET Core will do. To the point that you've now got legacy shops that are running MVC4 and MVC5. You look at it and go, "Oh, it's a bit old." Turn back time a little bit, and we've been here before again with ASPNET 2005, which was where ASPNET got good, with membership and generics and all that stuff, and that was a big shift from the previous world of one. .NET itself was a huge shift. ASP was reimagined to ASPNET in 2002. There was a lot of investment in VB6 and classic ASP before .NET came along, and .NET was the great big new thing at the time. And VB6 before that was the big new thing, because that was visual application development and drag and drop stuff and rapid application development. And that was replacing all this, which was old school C++, Win32 API development, and so on and so on and so on, back to COBOL and back to people using abacuses and writing stuff out longhand. The industry keeps changing. And you can't afford to stay still, and neither can technology vendors like Microsoft, which is why everything keeps evolving, and the only thing you can really do is keep going with it, because ultimately we get to a better place. So looking at some of the differences in .NET since 2001, back then we were looking at a world of many languages but one platform. So you could write .NET in VB, in C#, in COBOL if you really wanted to, or JScript was a thing and all that stuff, but it was, it was one .NET VM and one .NET framework underneath it. It's kind of switched around now. C#'s more or less one, but it can run pretty much everywhere. With .NET Core, you can run on Windows, Mac, Linux, Raspberry Pi, whatever you like. And what you get with .NET Core is something that's cross-platform. Tooling is cross-platform, the common language runtime is cross-platform, the foundation class library is cross-platform. It's portable. You can create applications that are isolated. You can literally get a folder and you can X-copy it to a server and it'll run. And it doesn't need anything else on the box, it will just run. Because you can bundle the whole runtime up with it. And you've got .NET Standard, which standardizes the .NET APIs. It's essentially portable class libraries done right, but without the pain that you used to have with portable class libraries. You don't have to worry about what version you're targeting. You can just say, this is the standard I conform to. It will now run on full framework, Core CLR or whatever. We'll get onto that in a bit. And it's fast. They've ditched all of the legacy cruft in system.web. They've made it more modular. So you're now not pulling in the kitchen sink when you run a simple web page. You can pull in only what you need for your application to run. And it's significantly closer to the metal. If anyone's played around with the new abstractions like span, you've got new abstractions that let you do safe direct memory manipulation, which is how a lot of the performance improvements have been made. So a lot of the stuff that you used to have to break out into unmanaged code or C for, you can now do in C# itself. It's also open source. All of the source code for .NET is now online, and I would recommend you at least have a quick look at it, if only to see how Microsoft structure their source code. Because for all the flack they get, they are still a professional outfit, and their code is interesting to look at because it looks very, very simple, to the point of you looking at it and thinking, is that it? And then you drill down and you realize you've got lots of little methods combined and combined until eventually you get complex systems like system.data.sql client. Unless you look at system.string, which is just all pinvoke everywhere. That's it. It's just Win32 APIs all the way down. And it's also, by virtue of being open, open to modification. So that, for example, is a screenshot of a chap called Franz Baumer fixing a bug that he knows of in SQL connection. Everyone is free to submit pull requests to the .NET framework. Obviously, Microsoft are free to reject them as well. But if you've got any problems that you find in .NET, you can now not only look at the code to see exactly what's going on, you can fix it if you want to. So what exactly is .NET Core? What are we really looking at here? Well, there's quite a lot of things that all come together that we mean when we say .NET Core. Underlying, you've got the infrastructure of the Roslyn compiler and the rewritten MS Build, which is now cross-platform. You've also got the .NET Standard, which ensures that you can write truly multi-targeting class libraries. In the middle, you've got the core of .NET Core, which is the common language runtime. And this is a rewritten from scratch version of the Core CLR. Totally cross-platform, more or less rewritten from the ground up. This is the thing that's actually running your code in production. On top of that, but separate, you've got the Core framework, otherwise known as the foundation class library, or foundation class libraries, I should say. This is stuff like system.data, system.io, system.security, all the libraries that you would pull in to actually do any real work most of the time. Most of those have been, if not completely, then significantly rewritten. generally speaking, to break up dependencies or isolate platform-specific dependencies. And in other cases, for example, system.net.http client has been rewritten so that on Windows it calls into the Win32 API and calls WinHTTP, and on Linux it will use libcurl to do the same job on Linux or OS X, but still present you the same API to use as developers. Finally, very top, we've got the actual application layer libraries. You've got ASPNET Core. Again, it's just a library. You can pull it in if you choose to use it. You've got Entity Framework Core, which again is worthy of another talk in its own right, but is a completely rewritten version of Entity Framework. Kestrel we'll get on to in a minute, which is the new internal web server, or default web server for .NET Core. And then off to the side, you've got a whole new set of abstractions around configuration and logging and error handling and so on. These replace things like system.configuration or the old trace source and the system.diagnostics libraries with abstractions that are frankly a lot better and that are much more pluggable. They not only plug into application layer things like ASP.NET Core, but you can also much more easily plug your own implementations into them. In terms of flavors, the full framework is still around for now, will be maintained and will be getting security fixes and patches going forward. It is unlikely there will ever be a .NET 5. It's more likely it will just continue having minor versions on .NET 4. Probably, it looks increasingly like that will start entering long-term support in the next few years, certainly as WinForms and WPF start to move into .NET Core. So it will still be around and Microsoft will still support it, but .NET Core 3 is likely to be the breaking point where features start going into Core that don't ever really make it into the full framework. So this is the point where they start bifurcating. You've got .NET Core, which we've been talking about, and you've also got Xamarin, which gives you mobile application environment. And underpinning all that, again, you've got .NET Standard and you've got Roslyn and MS Build. And what that means is that you can write things like your business logic in Net Standard. You can compile it with Roslyn and build it with MS Build, and you can then choose which of these platforms that stuff is actually going to run on. So you've got more choice, even though really this stuff is going to start going away at some point in the next few years. I've been talking about .NET Standard, and this is it. It's important to mention, don't panic, it's not as bad as it looks. It's really simple when you get the hang of it. He says, then looking at the sliding, trying to remember what it is. Essentially, .NET Standard standardizes, for want of a better word, the APIs that are available to you in the .NET framework. So if you target .NET Standard 2, then your application can run on .NET Core 2 and onwards. It can run on the .NET Framework 4.6.1 and onwards, Mono 5.4, and so on down the line, Xamarin, UWP, etc. Obviously, if you've still got Silverlight stuff that you're maintaining, then that's a problem that you probably need to solve, and you need to go all the way back to .NET Standard 1 and possibly get yourself another job in the process. Interestingly, Silverlight was the original .NET Core. Silverlight was the first time Microsoft had to write a CLR that was cross-platform, so that developers could write ASP.NET that ran in a browser plugin. The work they did as part of that was the thing that eventually became .NET Core. So it's dead, but it kind of lives on in another guise. It did not die in vain. I never used it, so I don't have any great fondness for it. But then if your application, for example, needs to target .NET 4.6 or 4.5 even, then you go up the chart and you find the lowest common denominator, and you say, right, I need to write a class library that targets .NET Standard 1, because I've got this ancient scrotty application that I can't move off .NET 4.5. That's basically it. When you target these different versions of the standard, you will get different APIs and different methods available to you. So if there's a particular API that came along in 2 and you then have to target 1.4, you can't use it. Compiler will break. If you then upgrade your application to .NET 4.6.1, brilliant, you can upgrade your standard. Generally speaking, I don't see a lot of things that are... What you tend to see in the wild is 2 and 1.3, anecdotally. So, like I said, it's important not to panic. It's not as complex as it looks. If you're only writing .NET Core, as in it's a pure .NET Core through and through application, it is very easy. You simply target 2. Everything is 2 until 3 comes out, and then it's 3. So this is a slide that is going to be obsolete next year. At the moment, with .NET Core 2, you can still run ASP.NET Core on the full legacy .NET framework. So, remembering back to this slide, ASP.NET Core is just essentially a set of class libraries. It's an application framework in its own right, written in .NET Standard. Because it's in .NET Standard, it will run on the old runtime. So, in practice, if you've got an application that looks a bit like this, and you've got old .NET 4 full framework libraries that you can't migrate for whatever reason, a good reason we've got at the moment in Cascade is that we've got a license for an older version of ASPO's words that I'm still waiting for purchase sign-off to upgrade. That means because that doesn't target .NET Standard, it can only run in the full framework. But it can still run against ASP.NET Core. Your .NET Standard libraries can run against both. So an ASP.NET Core application targeting the full framework can inherit the same library as an ASP.NET Core application running on the core CLR. You might have gathered by now that this talk is a competition to see how many times I can say core in the same sentence. Quite a lot, as it turns out. And these can run on totally separate runtimes. So I'll give you the example that we've literally just had the last week or so in Cascade. We are building a whole new UI which involves some ASP.NET Core APIs and an Angular frontend. And up until recently, it was all full core CLR, totally cross-platform. We were looking at building it and running it on Linux. We then came to implement an API that renders payslips. And it renders payslips by taking a load of data, chucking it through ASPO's words, which is an old version from 2014, which we're still licensed for, and then returning you a PDF at the back of that. Because we can't, at the moment, upgrade that library because our purchase approval system is horrific, we're stuck. So we can only target the full framework. However, that's not actually that big of a deal, because all we do there is say that this API, it's got the standard common libraries that it shares with everything else. We write a separate little web API that targets .NET 4.6 or .NET 4.6.2, I think, brings in that legacy library, but we're still writing ASP.NET Core, which means we can still take advantage of all the new logging frameworks and the new configuration options and all the new good stuff that's coming in ASP.NET Core without blocking us from delivering a new architecture. And actually, when I get approval to upgrade that library, all we do is we retarget that application at the .NET Core CLR, and that's it. It's fine. So this, if you do have legacy dependencies that you can't get rid of or can't get rid of quickly, it doesn't block you. Now, having said all that, this is not possible in 3, at least according to Microsoft at the moment, unless they change their minds. Microsoft have said that ASP.NET Core 3 will only run on the .NET Core runtime. So as soon as you get to 3, that's it. It's core all the way or nothing. However, 2 is still in long-term support, which I believe will be about sort of 5-10 years or so. So if you do have the situation, you're basically restricted to .NET Core 2 until you can find a way to get around those dependencies. So that's your sort of hard break point. They toyed with doing this in .NET Core 2. They chickened out of it and backed off. With 3, they've decided to just go for it. So that's the decision point. If you want to move up to 3, it's all or nothing. I would always recommend, if you are in that situation though, stick with 2 until you can get that little set of dependencies gone, and then you can start looking to upgrade. In terms of how you might look to migrate existing applications, for me it's basically come down to 2 choices. Let's say you've got your legacy system with your old class libraries, your old application, and your old external dependencies. You either choose to partition the application into this is core and this is not core, or you do what we did in the last slide and run the whole application on the full framework until you can snip off those dependencies or replace them. So you either say, right, everything I can port over to .NET Standard, I'll port over. The bits that have to run on the full framework, I'll separate that out into a virtual application or a separate website or something that segments it off, and that can just keep on going. And then everything else, that can all happily run on .NET Core. Alternatively, you say, we'll run that application on the full framework, even though we'll rewrite it for ASPNET Core, MVC, etc., until we can get those dependencies moved off. Totally depends on your application. Everyone's completely different. A few other things around migrations that are worth talking about. If you are the maintainer of a WebForms application, there is no way but to rewrite. They're not proposing to port WebForms ever to .NET Core, so it is just a simple case of we need to rewrite this stuff. Class libraries, you can move. The actual UI markup, you can't. If you've got old school MVC, you will still need to do a fair amount of porting, and it will probably be a little bit painful, depending on how complex the app is. It will end up being a lot simpler, and if you've got an application where you've got MVC and Web API running side by side, you'll end up with something that's a lot simpler because they're now both merged into MVC. They're not 2 separate things, which means you don't have that weird situation where MVC has config in global ASACs and Web API has the startup file, and you have to have your 2 DI pipelines and so on. That all goes away. However, if you've got a lot of complexity surrounding that, it's going to take your time to do. So again, you might be better off starting at the class library side, potentially writing some new experimental applications in .NET Core, getting experience, and then moving on to migrating the big application. That was the warning about .NET Core 3, which I mentioned earlier, so ignore that one. What we gain with .NET Core 3, the minuses have basically been crossed out as I've been doing this talk over the years. When I started, it was hugely complex, it wasn't backwards compatible, and you couldn't do desktop development. Those minuses are now being eliminated. What you get is cross-platform, more flexibility, portability, speed, because it's insanely fast compared to how the old .NET framework was. 1 million requests a second and things, stupid benchmarks like that. The original promise was that you'd get very fast releases. They've rode back on that. The original promise was that because everything was a NuGet package, they could upgrade system.io and you could pull that in anytime you liked. That caused a lot of problems. So they've gone back more to we've released 2.1, released 2.2, and all the packages get upgraded alongside it. And of course you get shiny, because we all love shiny. In terms of new stuff, loads of it. We get the .NET CLI, we get a full command line interface for .NET, which means you do not need Visual Studio to create new projects. You can just script it. CS proj files, huge improvements, hugely slimmed down to the point they're almost readable now. We've got .NET Standard. We've got MVC Core, which is a completely rewritten web application framework. It's MVC combined with Web API in one big happy platform. It plays nicely with IIS. It's got consistent error handling, and it is lovely compared to working with MVC. Entity Framework Core, totally rewritten from scratch, totally cross-platform, trimmed off of all the SQL Server dependencies that SIX and its ancestors had. Kestrel, a built-in web server that can just run. No need to have IIS expressed, no need to have IIS running. You can just run your application from command line. Middleware replaces HTTP modules and handlers. MVC is written as middleware. It's basically a very simple abstraction to say if you want to do something in the HTTP pipeline, write it like this, and it will just execute. So security, filtering, request modification, all of that is very, very easy to write now. And everything, absolutely everything, is wired up for dependency injection. It is almost impossible not to do dependency injection in .NET Core, or it is very, very difficult, although I have seen it done, and it's horrible. You really have to hack it not to do it. DI kind of came along a long time after .NET started. You kind of have to hack it into the full framework. It's totally turned around in Core. And what that means is that everything is really, truly testable. You don't have to do any sort of hacks to try and work around hidden magical dependencies. It does mean that things are a little bit, you need to do a little bit more work to get things set up, and you can't rely on sort of magic statics like HTTP context.current. But ultimately you get a more flexible and stable and testable product. In terms of hosting, we've got quite a few new options now in the .NET Core world. If you're on Windows, you can choose to host Kestrel and just Kestrel. You can expose the ports to the internet, and you don't need any other web server, and Microsoft will now fully support that. They don't recommend doing it, but basically you can simply compile it as an exe and run it, and that's it. That's your entire website. You can stick Kestrel behind Nginx if you want to do that, or possibly Apache or any other web server that gives you some sort of reverse proxy. Or if you want to keep using IIS, you can choose to use the ASPNET Core hosting module and Kestrel. And what that effectively does is reverse proxies your application into Kestrel. I'll talk about that in a minute. And as of 2.2, you can now run ASPNET Core applications in process, which gets you higher performance, but does tie you more to Windows. So that's deeper integration to IIS at the cost of a little bit less flexibility. If you want to run cross-platform, you can also run Kestrel as a bare server, or you can run it behind Nginx. And again, just to talk you through what that reverse proxying looks like. If you're doing this model, your web server is basically sat in front and forwarding requests back to your application, which is running in Kestrel. Briefly touched on the new project system. This is a CS proj file for a website. That is a full project file for a 2.2 website, and that will run. There are no GUIDs, there are no horrible scrotty bits of XML, and it is easy enough that you can almost type it from memory. No separate packages config, they're all included in here. Massively slimmed down, but still works with MS Build and still works with your existing build systems. That's the important thing. You can multi-target, so you can choose to have a class library that builds for both Net Standard and a legacy platform. And if you choose to multi-target, you could even choose to include different dependencies depending on what you're targeting. So if you've got different versions of libraries, that one of which supports Core and one doesn't, you can do these sort of conditional includes in your project files. I've not had to do any of these for a long time, by the way. Every package I've used recently has supported .NET Core and .NET Standard. More importantly and more interestingly, self-contained deployments. you can, when you're building the application, say, I'm building this for Windows and OS X, and you will get two sets of build artifacts, both of which will have the full frameworks baked in for that platform, which means that your build for OS X has the OS X binaries in, your build for Windows has the Windows binaries in. You can do that in your project file, or you can do it from the .NET CLI. A load of problems just go away, such as assembly binding, differences between MVC and Web API, and having to plug in your own dependency injection. Local developer configuration, if anyone has web.config.template files, that problem goes away. I'll show you that later in the demo as to how that works. And because you've now got a consistent web pipeline, error handling suddenly becomes easier because you've only got one pipeline handling static files and ASP. So you can stick an error handler at the top of that and it'll catch everything. A lot of things go away. You lose system.web, you lose WebForms. WinForms is coming back. And if you're heavily reliant on system configuration, you'll have to do a lot of rewriting around that. They are annoyingly supporting Entity Framework 6 soon, which I don't understand really, but they're doing it for reasons best known to themselves. If you've got a lot of heavy dependency on EF6, it might be of interest. Otherwise, I'd recommend EF Core. Coming in .NET Core 3, there's a few minor things like they've trimmed EF Core out, the standard packaging. They've taken JSON.NET out, and they've written their own JSON serializer, which is meant to be a lot faster. So you can still use JSON.NET, but you've got to pull it in as an external package. It's only going to run on the core framework, as I mentioned. And they're bringing in much deeper out-of-the-box integration with libraries like Swashbuckle and Identity Server and Beatpulse. And, I won't do a spoiler because the chap's coming in next month to do it, you've got Razor components and Blazor, which is the exciting bit, which I don't know enough about to talk about. In conclusion, I can smell pizzas and everything is awesome. So, break for food and then we can do the code demo. Cool. So we're going to have a little bit of a look through a sample application that I've used for this event. It's really simple. It is really basic. It's not meant to be an example of great programming, but it'll take us through some of the new things that are available in .NET, in ASPNET Core specifically. So all it is a really simple blog site. So you've got a web application that runs it, and we've got some unit tests, and I think 3 unit tests that should pass. Okay. We'll get onto the unit tests a bit later on. They're probably one of the more interesting bits because you can do a lot more around integration testing and testing the actual website than you could ever do in old school MVC. We've got basic client scripts, we've got controllers, we've got some middleware, we've got some EF Core in there with some migrations, models, tag helpers, views, and some settings files. First thing to mention is that all ASP.NET Core web applications are console applications. So they are designed to be run from command line, and they will all have a program entry point. Because they're command line applications, you can do whatever you like in terms of taking in arguments that trigger certain behaviors or don't trigger certain behaviors, because at the end of the day, it's all code. So you can have debugging flags or test-only flags or whatever you like. You can all inject it in there. In this case, this is where I'm also initializing my entity framework context. So we're loading up my EF context and we're initializing it. And what that means, I go into SQL Server and delete the database. If I now go to command line, make sure I'm in the right folder, yeah. It will blow up horribly because I'm in a demo, and that's what things do when you're in a demo. It should create the database. So, boom. What it's actually done there is look at my migrations file. It's created the schema. So if I go back into SQL Server, I've now got my database there. It's got tables in it, and if I select out of that table, I've actually got some data in there. So again, I'm not going to talk too much about Entity Framework Core because that's a separate topic in its own right, but that's all handled through these migrations. Entity Framework Core also has a rich command line support, so you can do migrations, you can create them or apply them through command line. So again, separate talk, but worth reading up. So what does it actually look like? And behold my design skills. Believe it or not, I actually started life as a web designer back in the early 2000s, but I haven't used the skills here. It's a really simple blog application, shows you your posts, lets you click on them, gives you a simple about page, and lets you write a post. So and it lets you use Markdown syntax. And that's it. We've also got this little thing down here showing how long it took to process the page. So as we click through, we can see exactly how long it took to spit that out from the server. And we've got some custom tag helpers. Believe it or not, these little tags are using tag helpers to render themselves. So under the cover, what does it look like? Well, if we go through startup first, again, this will be fairly familiar if anyone's used Web API, but in a ASPNET Core world, this is your website configuration. It's the equivalent of global ASACs and startup all combined into one. This is where, with access to your configuration, you can configure all of your injected services. So in this case, we're adding a database context for Entity Framework. We're telling it to use SQL Server, and we're configuring it to use the relevant connection string. We're also configuring a settings object, and we are adding a transient dependency of type blog service, which we'll look at in a bit. And then we're adding MVC. And again, this is important to note. MVC is just another bit of kit that you plug into your pipeline. It is no more important or less important than anything else in there. If we look further down, static files is just another bit of middleware that we plug into the pipeline, as is MVC. So I mentioned middleware earlier. All of this configures our HTTP pipeline. So we start by plugging in this bit of custom middleware, but you can, if you want, simply write a Lambda function to do exactly that. So you get access to the essentially the incoming request context and the HTTP context, and you can simply just write code here. So the very minimum ASP.NET website is literally just use anonymous function and write hello world out to the browser. So you don't even need MVC to use ASP.NET Core. In this case we are, so we're plugging MVC Core in down here, along with static file support, which again you don't need if you don't want, and a little bit of stuff around redirecting to HTTPS and using error handling. HTTPS is quite nice. You get that out of the box with .NET Core. It will automatically install a local developer certificate and trust it for you. So you don't need to stick that certificate in your trusted cert store. It all just works out of the box. And by default, as of 2.1 and definitely as of 2.2, can't remember which, everything is HTTPS by default, because that's the way the web's going these days. Digging into that middleware, so this is our custom bit of middleware here, and that's the thing that's generating this little bit of text down there. And this is all it is. So I mentioned before that dependency injection is pretty much everywhere. A bit of middleware, all it needs is a reference to the next request delegate, and then every other parameter in the constructor, it will try to resolve from its internal DI container. So settings and logging. All that it then does when you invoke it and give it an HTTP context is start stopwatch, add that stopwatch to HTTP context.items for later use, and call the next middleware. So middleware works like a pyramid. The topmost one calls the next one, which 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 calls the next one, all the way down, and then at the end it goes all the way back out again. So that little await next is everything else in the application. And if we look back at startup, because that's the topmost, that is then error handling, exception pages, HTTPS redirection, static files, and eventually MVC. Once all that's done, it comes back out, and we get back to here. And there's a silly example of stuff to do. If we have taken longer than our configured minimum page loading time, we're going to log a warning so that operations can see what's going on. And then when we get into the actual views and we look at the layout, we can load that stopwatch from the HTTP context, and we can just display how long it took to render that page. So it's a silly example, you wouldn't do it in production, but it shows you you've got more or less complete control over that pipeline. You don't need to use MVC. If you've got fairly simple needs, you can do it all in custom middleware. If you've got some weird and funky custom authentication, middleware is brilliant for that, because you can inspect everything that's coming in, you can put cookies on, you can set context items, you can set session variables, all of that you can just do. It's a little bit, it's almost going back to the old ASP and PHP days where you've got complete control of everything from start to finish. And again, all the built-in authentication in .NET Core is also delivered as middleware, so everything is using that pipeline. The controllers should look pretty familiar too if you've ever done an MVC. Again, constructor injection is enabled everywhere, so all you do is define a constructor and you pass in your services, and so long as they're registered, the built-in DI container will just resolve them. You can plug your own container in if you want to. Over the last 4 years I've never had to myself, but if you've got specific or more advanced needs, you can do that, or even if you just plain like the DI container you're using at the moment. Other than that, it's what you've seen before in terms of controllers. This is a new thing as well. If you don't want to inject settings in the constructor for performance reasons or anything else, you can inject them via parameters, and if you decorate them with from services. Useful if you've got a service that's used in one method of your controller that's got an expensive setup time that otherwise would be just wasted. Otherwise than that, it's MVC as you know it. The views, again, not a huge amount to show in the views, but if we look at our index, there's a few new things. These tags here, you can just about see it on the screen, that are purple rather than red. That's a case of ASPNET tag helpers. You've got a few tag helpers out of the box, and this is a good example here. In old school MVC, you would write html.actionLink and give it the parameters. That usually ends up looking quite ugly, especially if you've got complex classes or custom attributes and things like that. What tag helpers let you do is mix server-side markup with client-side. So these magic ASP tags, you've got them for area, controller, fragment, and so on and so forth. All of these are bound and run server-side. So in this case, I'm saying this link routes to the action of blog, and it has the root parameter ID of this, which I get from the blog post. What you get from that is much cleaner markup that looks a lot more like HTML. It's a lot easier to read, and anything that is non-server-side, you can just write as a normal HTML tag. So it gives you a lot cleaner markup. You can write your own of these. So here, for example, I've got a custom markdown tag helper that's converting this string to markdown, or sorry, converting this markdown to HTML. Here, I've got a custom span that's doing a tags view. So I've got a string that represents a comma-separated list of tags. That's going to render it out into a nice, friendly display. The one I always love writing, and I always include it in projects, is if. If this condition, render this. If that condition doesn't exist, it doesn't render this. And it just saves you putting that extra if clause around something. And again, when you actually see that in practice, it looks a bit like this. If we have a look at those custom tag helpers, this is our markdown one. Very simple. All we're doing is saying, I want to target an HTML element of markdown, and that can be any string. It's totally arbitrary, so you can have your own. It's going to have this attribute. So if we go back to index, you see markdown text equals. That's what this is doing. And then when we render it, it's very simple. We're just outputting a div tag, and we're setting the content of that to whatever markdig converts that markdown format to. That's it. If we look at the conditional one, it's slightly different. We've got the attribute saying is visible. This up here is saying that this tag helper kicks in if the element has an attribute of if. So if I go back here and go OL if, suddenly that's now a tag helper. It's not if, it just renders it as normal HTML. So you can target existing elements, which is what the ASP action attributes do, or you can create your own, like we're doing with Markdown there. And all this one does is say, if it's visible, continue to process the internal content, and if it's not, suppress the output and just don't show it. And finally, the comma-separated tags helper. The only reason I've included this is to show you that dependency injection also works in tag helpers. So in this case, it's a stupid example. Within our settings file, we've got this block of app settings, and we're saying that tags should be surrounded with a mark tag. Because we've wired this up in startup, there, we can now, in our tags helper, get these settings through use of iOptions, which is part of the whole configuration framework, and we can just use that configuration value to render our desired HTML. So that's tag helpers. Configuration I touched on. Again, briefly, because there's an awful lot to it. By default, configuration files are in JSON. However, the out-of-the-box setup will also override any values here with any environment variables or command line flags that you pass in. So the way configuration works in .NET Core is that you basically describe layer after layer, and they will override each other, with the last one winning. Great thing about that is you can use this thing called user secrets, which is baked into Visual Studio. If I can find where it is, manage user secrets. You can define your own connection strings and settings here, and they will override whatever's in configuration. And they live on your machine outside of source control, and they cleanly integrate. So if you've got an environment where each developer machine is subtly different, you can just maintain your own set of secrets, and you don't have to mess around transforming template files or changing values, or remembering not to check in the config file for your machine, and then forgetting and breaking the build. I would never do such a thing, of course. In terms of what formats are supported, XML, YAML are all totally supported for this as well. And if you have a need for a different type of config, the abstractions for configuration providers are again totally pluggable. So if you've got your configuration in SQL Server, you can write your own framework to load it from SQL Server. And it can then override things that are in here if necessary. What else? So EF Core I'm not going to go into too much other than to say it's there. So we've got our context object. Our context object has a little bit of data initialization in, but again, that's more suited to an entity framework core conversation. The important thing to note is that with EF Core, there is no dependence on SQL Server, and the underlying database engine is completely pluggable. So going back to startup, we're saying, I want to use this database context, and I want to plug in SQL Server to it, but equally, we can bring in a PostgreSQL, we can bring in a MySQL package or a DocumentDB package or anything else that's supported, or write our own, and it will integrate with Entity Framework Core. That becomes really useful with the bit I'm now going to show you, which is how you test all of this. So going back to our Test Explorer, and if you take nothing else away from this, I'd encourage you to take away the testing side of it, because it's, as far as I can see, revolutionary. Once VS actually wakes up and runs these tests, they should all pass because they did 3 hours ago. Yeah, or not. Yeah, anyway, I'll carry on as if they did. That's why. That's running. These tests are all defined here. So we've got our 3 tests defined using XUnit in this test library. This uses the ASPNET Core test host and test framework. This is a framework for testing websites, but instead of testing an MVC controller as if it was a standalone object, this actually tests the website. And what it will do is spin up an instance of your application in memory and hit it as if it was a real-life web application. So any middleware you've got in there, any configuration, all of the HTTP context, all of the request context, all of that is totally available and totally there to test. As far as .NET is concerned, it's actually running itself as a web application, which is great because you don't need to fake a load of stuff around HTTP context, and you can actually get a proper test of how your code really behaves. So if we look at some of these, there we go, all pass. We've got a test here that is trying to create a blog post. So I'm creating a new simple object that represents all the parameters for posting a new blog entry. And I'm going to post that. So using this web application factory, which is built into the testing framework, if you can see that, it references our startup object, so it knows this is the website to spin up. We inject this and keep it around. We then create an HTTP client from it, and this is where all the DI stuff starts coming together. So using our factory, we can spin up a web host builder. We can then use this cool little extension method there, which again comes out of the box, to configure test services. So you can essentially override any services that your application uses with fakes or mocks or stubs. Now in our case, we are going to use Entity Framework in-memory database, which again is a Microsoft package that you can just plug in. And then we're going to tell Entity Framework that it's going to use this in-memory database. So as soon as our tests spin up, we put an in-memory database. As soon as they finish, that database goes away. You don't have to have SQL Server around or anything, or SQLite, or anything like that. And then we're finally going to create an HTTP client at the back of it, because these tests are basically assuming we're a user. So our test is going to post this information. I've got a tiny little extension method here that just converts that to JSON, then converts it to a form URL encoded message. It could be JSON, could be however you want to actually post that information to the server. It's going to do the post, and then it's going to get a result. What it's then going to try and do is try and go to the blog that we've just created using that URL slug. And then it's going to say, I expect that to be successful. Now we've got another test down here saying if I try and go to a blog post that doesn't exist, I expect to get a 404. So you're verifying it as if you're an actual user. So it's much more of an integration test than it is a unit test. But if I go into the controller and go into the write method, I can now debug that, step through it as it spins up. I get the breakpoint and see the model there. But I can also get everything else in the context and everything else in the pipeline. So I can step through this as if this is an actual live application. In this case, it's going to return me a 400 for some reason. The model say it's not valid. So you get all the validation middleware put in there as well. That all happens automatically. And then we've just got another 2 tests down here for check that you get a 404 if you get a non-existent post, and check that if you supply a invalid model, you get a 400 response. So this doesn't replace unit testing of your class libraries, but it does give you an interesting alternative to heavyweight Selenium tests for the website itself. They run fast, they run very much quicker than Selenium does, and you get more or less the same experience. You can't obviously do things like simulating button clicks on JavaScript and all the other stuff that Selenium would give you, but for stuff like checking APIs or checking if the returned HTML contains a substring and things like that, all of that you can do. So for me, that's really one of the biggest things that the .NET Core or ASP.NET Core brings to the table. Any questions on all of that? And we've been wittering on for a while, so. All this is available on GitHub, by the way. I think I'll give Kev the URL to share around. Or anything .NET Core related. Everyone just wants to get down the pub. Fair enough. Cool. Unless there are any questions, that's really me done. Like I say, there is a load of stuff in .NET Core you can go and learn. The best way is just to get it and play around with it. There's far more than I could talk about in the time we've got here. Yeah, that's me, other than to say it's awesome, go out and do it, and convince your boss that you should be doing it.